Welcome to the workshop here at Waterbearing. My name is Marty, and I thought I would share the process of sort of making a spout. I have a project here that has some no common design elements that I deal with all the time, and it's sort of a good example of what I do. So, with that, uh, I want to make a stainless steel Oona spout. This one happens to be in bronze. I sell these in a variety of finishes and colors and such. But I thought stainless steel, yeah, that would be good. This shape lends itself well to stainless steel, I think. And it would be interesting to see what it looks like and if people want to buy it. So I had some of these parts cast in stainless steel, and so here they are. There's essentially two pieces to the spout. There's a back plate and a cylinder, and you just sort of pound the cylinder into the back plate, and it does get welded, so you don't have to worry. There's a couple of holes that need to get drilled in the back. There's a hole for the bonding wire that needs to get drilled, and there's a hole for a set screw in the front. I think in this one, what I'm going to do is I'm going to press fit a fitting into the back for the threads. So if I could, yeah, so essentially like that. So I got these cast. I thought, all right, take them over to a polisher, see what we can get. And I got this back, and I thought, yeah, this is looking pretty good. I could live with this. This is kind of what I had in mind. And then I started looking a little closer, and I started talking to the polisher. And well, there's some details here. There's some areas that couldn't be polished because of the way the spout's designed. And well, neatness counts. Getting these details right is important. I think if I were to order this from somebody and get it in the mail, I'm not sure I'd be happy. So, it kind of behooves me to fix the problem. So, you're not going to be able to see it this far away, but so let me change the camera angle a little bit and do a little close-up, and we'll look at it that way. So with that, okay, here we are up close and personal with the spout. It's beginning to look pretty good. You can see that it's polished, it's sort of similar to a number 4 brushed finish. But the problem is that there's a raised lip here around the edge, and you can see some pitting. It's not really pitting, it's the rough surface that's left over from the casting process that the polishers were not able to remove. And the way this works is they'll polish it with a sanding band that is powered by a motor. So essentially what you've got is you've got a band of sandpaper sort of gliding along the surface. And you can see that this band gets in the way. It's raised, and so you won't be able to get into these areas around it. So step 1 is to get rid of that band. So the back plate needs to get redesigned. There's another problem. It has to do with the material itself. Stainless steel is pretty tough, and it's kind of hard to work with. And I think what I'll do is I'll set up a close-up on the mill, and we'll take a look at that as well. Okay, here we are at the mill. I've got the back plate set up in a fixture that's designed to hold this part at a particular angle, just so I can drill one hole down like this for the bonding wire. Now, the material that I'm going to cast these parts out of, a 316 stainless steel, is I think suited for pools. I mean, it doesn't rust very easily in very caustic environments. Oftentimes, this material is used for in ships and in laboratories where they need acid resistance. But the downside is it's really tough to work with. It's gummy. It work hardens easily. And by work hardens, I mean if you were just to put this drill bit down and sort of let it rub on the bottom without aggressively moving it through the material, the material will get harder and harder, and soon the drill bit won't be able to drill through it, and you'll dull your drill bit. So it's not a lot of fun. And ask me how I know. How do I know this? Got a whole bunch of dull bits to prove it. Any rate, this part was really designed to be made in bronze, and drilling this hole with bronze is no big deal. Bronze is a lot softer, it's easier to work with. Even though this flexes, it's not a problem with the bronze. Here in the stainless steel, it's not going to work. So the bottom line is I need to change this particular piece to accommodate the material. And, you know, I have to do that. That's just the way the game works. If I can't make the part the way it's designed, then something has to change. So we're going to change that. Okay, we're here at the wax table. I think it behooves me to have a discussion about how these parts are made, because if I'm going to redesign this, and I'm thinking about what it's made out of and what some of the other requirements for the part are, I'm going to also consider how the part is made. So these metal parts that I get that are cast for me start their life as waxes, hot pink waxes that I give to the foundry, and they turn them into these metal parts. And the process is a very old one. So what they do is they take the wax, they essentially dip it in plaster, then heat the plaster in an oven to melt the wax out and fill the cavity with a metal, in this case stainless steel. So you know, you give them this, 6 or 8 weeks later they give you one of these. So it's something that I do, and I make all my waxes. So to do that, I have molds. So here's the mold for the part that I'm going to redesign. There's essentially 2 parts to it. There's a cavity and core, for lack of a better word, and it's made out of silicone. Silicone's somewhat flexible, and the wax doesn't adhere to it. It's pretty easy to work with, and you know, you put the 2 parts together, and you're left with a cavity, and you just fill the cavity with wax. So let's do that. Oh, but let's get a better rubber band. Woo! That was a zinger. At any rate, okay, so I got to put together, and hey, look at that! I got some hot wax. We're good. All right, there we go. We're gonna fill it with wax. The wax isn't too hot. It's about 170, I think, 180. Okay, I'm gonna squish it around to get as many of the bubbles out. And there you go, the mold's filled. So now we wait for it to cool, and then we'll pop the wax out. Now, this is a fairly simple part to mold, but hey, this is pretty complicated. How do you do that core thing in the middle? How do you get that hole? Well, I'm not going to show you that mold. It's a bit too complicated, but I'll show you with a different part. This is the Kepik. Or this actually is a wax for the Kepik, and it's blue. You know, like, why is that pink and this is blue? I don't know. And the blue is because I use a different wax, and the injector has different properties. The pink flows very well, and it works very well for these molds. The blue doesn't. But the blue, on the other hand, is more durable, and it works very well in the injector, which I'll show you here shortly. So anyway, here's another mold. I've got a shell to hold the silicone parts together. We'll take the silicone parts apart. Okay, and there's something in the middle which is called a core, essentially. And this one happens to be made out of plastic. And we'll just take this apart. I'll show you how that works. And so there's 2 parts. This is a 2-part core, so there's the square part, I think, that goes like that. And then this part that goes into the back, but it's not going to fit. It's not going to fit because the wax here is thicker than on the shell, and it shrinks a lot. So, it doesn't fit, but hopefully you get the idea of how this works. And what the heck? let's fill this one as well. Let's inject it and see what comes out of the mold. So put it back. Is this the way it goes? I think so. Yeah. Okay. Let's see. This towards there. That goes like that. I put the clamp over it just so it'll hold it together. And then we'll inject it. I think what we'll look at next, though, before I inject that, and we'll inject both of these. This is a little metal mold that I made. And this is what pops out of the mold. It's these little wax pieces. So here, instead of using silicone to form the mold, I made the mold out of aluminum. Now, silicone, yeah, it's flexible. You know, you can get away with a little bit more. Aluminum, however, is inflexible. So if you design the part wrong, if you were not able to pull the part out like this, right, it's going to get stuck in there. So you can't have undercuts. The part must be designed properly. You need to have what's called draft, which is essentially let's see, yeah, you're looking at it that way. These edges are sloped ever so slightly, so it can pop out of the mold that way, right? If the edges were sloped the wrong way, let's see, if they were sloped that way, and you needed to get it out over here, it's not going to happen. It's going to jam, and that's what's meant by having draft. So here's a metal mold that I machined, and we're going to make a larger version of this for the redesigned part. And I'm just going to put this one together, and we'll inject it with wax as well and see what we get. There are reasons for doing that. I have a way of filling this mold better that works better than the way the silicone molds are filled, and I'll show you that here just in a moment. Okay, so let me reset the camera and show you how the injection machine works, and then we'll move on. Okay, so this is a wax injection machine, I think is the official term. It's used mainly in the manufacturing of jewelry. So what it is just a pot. It's got hot wax in it, and you're able to pressurize it, which I think I'm going to do that right now. Okay, so now it's wax under pressure, and it comes out of this little nozzle here. So I think what we'll do is we'll just fill this Kepik spout with wax. It's just a very simple thing. Let's see. Is the wax really under pressure? Can I get it all over myself by demonstrating it to you? Look, it's hot wax. How exciting. Okay, good. So it's just a simple thing. I just press the mold up onto the injection machine, and through the miracle of physics, the hot wax is injected into the part, and the wax is injected out. Maybe you can see that there's wax coming out of the end. That's the vent hole. So the mold is now full. This aluminum mold will do the same way. There's no vent point like this one where the wax gets everywhere. So I end up just holding it for 30 seconds or so. 1, 2, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15. You get to see me count on video. Isn't it exciting? 17, 18, 19, 20. Maybe I lost count. Does it feel like 30 seconds? Should have been 30 seconds by now. Well, okay, we'll call it 30 seconds. And so now the reason I want to do that is I want the wax in the aluminum mold to solidify a little bit and still have the pressure applied. Granted, there's not a lot of pressure here, but it still creates a decent part when I do that. So let's let these parts cool and take a look at what I got and what that means for the design as I move forward. So I'm going to take a little time out. You in Video Land won't see a thing though, but okay. Okay, so after an appropriate cooling off period, we're back. Take this the first mold apart and see what we got. I'll do it this way. There it is. There's the part. We'll just sort of flex this a little bit. And it should pop right off. And sure enough, it does. Okay, good. I think... So these parts come out pretty good. They do require some, I guess, post-processing is the word. This sprue needs to get cut off, and that's usually not a big deal once things have sort of solidified a little bit. I can just cut them. Yeah, I think that'll work. Like so. Let's see. What about you? Are you not cooperating? Come on, here's your chance at fame and glory. You can be on a video that the rest of the world can see, and you're not cooperating. Oh, please. Okay, anyway. Here we go. I'll just take that off. And then this I can just clean up either with a knife. I also just use a file, just file that smooth. There's a couple of other little glitches in the mold. There's a couple of air bubbles here that need to get filled in, and the way I do that is I take essentially a soldering iron for wax, fill these in, and then come back with either the knife or the file or some sandpaper and clean it off. And there's always some bubbles in the back. And these bubbles in the back are a function of the way the mold is filled and the way I designed the part. And I think at this point, we'll do a little close-up here, and I'll show you what that's all about. So let me reset the camera again, and then we'll take a look at the part. Okay, so here's the wax in the mold. And so the mold is filled up here, so this is up, obviously. And you'll notice, or I hope you can see, there's some bubbles here. 1, 2, and there's usually one here that's a small one. And guess what? Those are at the top of these cavities. And it's just the way this, because the way this fills, right? Wax goes at the bottom, and then the air travels up. And it gets trapped. There's an air bubble always gets trapped at the top of this cavity here. And it's just a function of the way this part was made and the way that I'm filling it with wax. So I'd like to do away with that. I want to get as few of those as I can, and if I can design the mold in such a way that these don't appear, boy, that'd save me a lot of time, because filling in each one of these imperfections takes time. And granted, it's only maybe 10 minutes a piece, but when you've got 30, 60 of these parts to do, that all adds up, and it could be a couple of days by the time all the parts get processed and cleaned. So I want to minimize this stuff and make the waxes that I get as clean as possible. So just for fun, let's take these apart and see what we got. This is the injection mold for that Kepik spout, and let's see, comes apart like that. Got a part. This is where it's filled, right? You see that there's 2 points with the wax go into the part. I needed 2, I found, after I was injecting it, because the part would not fill completely or evenly. But at any rate, so you can see the part surrounded in the cavity of the mold, right? The silicone, with the core around it. So we'll just pop that out like that, and we'll take it apart. And I need my little doohickey. This kind of lets me take that out, and then I'll take the square part of the core out. At least I will if I can. There we go. And this is what I have. And this requires just minimal processing. What I end up doing is just cutting these off with a knife. And let's see, I need to clean this part up a little bit, so I'll just shave it with the knife and then do something like that. That's pretty good. And then I'll do something here, something similar. This flashing will clean off. The surface finish is okay, but the big problem with this part, because of the two injection points, there's always what's called a weld seam, because there's two I guess edges or fronts of the wax that are cold, and they come together to form this weld or this seam. The wax is never very hot at the edge, and so I always have the seam to deal with, and it's not that big of a deal. I put some very soft wax there, clean it up, and I'm done. But this requires just a couple of minutes of cleanup work, whereas one of these waxes could be 5-10 minutes. So there's a big difference in the quality of the wax. Sort of the problem. I guess I haven't really figured out how to apply this to the part that we're making, and also I want to try an aluminum mold. Like we're going to take apart there. So let me get this stuff out of the way, and let me explain this mold to you. What do I have? Okay, this. I need to take this apart. Okay, look, this bottom fell off. So this is where it got injected, and you can see the remnant of this is the injection port, as it were. And the wax goes through the bottom, and I'll show you what happens on the other side. Look at that, popped right out. The wax comes up into here and flows around and up. Whatever air there is escapes through these very, very narrow passages. They're about I think 5,000 7/8 thick on this in this mold. So let's see. Can I get this one out easily? We'll see. Is this one going to cooperate? Yeah, look at that. Oh, hello. Okay. So there's a little bit of flashing, which I can just peel off with my hand, and then I'm done. Well, for me, I'd have to cut this out. But I get a relatively nice part with very minimal work in the end, and that's what I'm after. So we're going to make something similar to this, granted bigger, for this piece, and hopefully it'll work out. I'll get a nice part that requires very minimal work after injection. So that's the goal.